Hi everyone, my name is Girish Bhavre. I'm a senior product manager on AWS and I focus on EC2 Image Builder.
Hello and welcome. My name is Paul Hoffman. I'm a Senior Manager of Product Management here at AWS. My team focuses on tools and services for enterprises so it can make it easier for them to use the cloud capabilities of AWS.
Hello everyone, my name is Sahil and I am a software engineer inside the EC2 Image Builder team under AWS, and I'm pretty much responsible for the development of most of the projects going on in the team.
My name is Brett Aber, and I'm a systems engineer for the AWS Launch Wizard service. One area I focus on is improving the customer experience with new and existing applications, and I'll be walking through today's demo.
Hello everyone, welcome to our AWS Virtual Workshop. Today we will help you build and deploy your cloud workloads. The agenda for this workshop is how to build your golden images and deploy third-party applications on AWS. This slide shows the array of tools and services that helps you with each phase of your cloud adoption journey. We have offerings to help you during your assess and mobilize phase, with many tools available to support your decision-making and planning process. Once you have started the migration process and are running workloads on AWS, we offer a broad set of capabilities to run and manage Windows workloads on AWS. We offer services that are simple, console-driven, and support Windows, and we'll discuss in more detail later in the broadcast. We also offer Windows integration with our larger ecosystem on AWS. Our tools and services are designed to help modernize smoothly, with services such as Porting Assistant and App2 Container helping you with that smooth transition. Today, we'll focus on two services, which are EC2 Image Builder and AWS Launch Wizard. Many customers rely on Golden Image Process to safely run their workloads. This image management process requires dedicated infrastructure to continuously run latest images. That process is complex and takes away time from your feature development process. Moreover, additional effort goes into debugging and downtime. And when it comes to patching, lack of consistent processes sometimes lead to error replication across different versions of images, and it can become an operational nightmare to pass those images across multiple AWS regions. Finally, all these challenges lead to an increased lead time and slows down your feature development. Here we look at a quick overview of how Image Builder provides a repeatable construct to manage and create your organizational customizations for your output images. Customers can generate an automated pipeline on AWS Console, CLI, and API to produce Linux and Windows images to use on-prem as well as on AWS. You start off with a base image and apply your organization's customizations uh, to the image. We also provide AWS managed templates to accelerate your image customization process. Whenever a software update is available, Image Builder automatically produces a new image, runs tests on it, and distributes it to stipulated AWS regions. Image Builder is a free service, and you only pay for your underlying AWS resources when you create and store your images. Some of the examples of image customization is maybe you can add a couple of applications to your services. You might need to test certain configurations so you can ensure security patches are applied, strong passwords are enforced, or for example, your disk is encrypted and so on. And finally, once you have tested all those use cases on your images, you can now promote that image to production and distribute them to your desired destination accounts. And all of this is available as a repeatable construct, which reduces the variation and makes the process more consistent overall. Image Builder is also deeply integrated with a wider AWS services. And as you can see on this slide, we have integrations with a wider AWS platform, such as SNS. So you can use SNS to track your latest images, error logs, and custom events. With private link, you can privately access Image Builder from your VPC without using your public IPs. You can write custom automation using CloudFormation and maintain tighter control over your image distribution using AWS organizations. Finally, you can also incorporate inspector security workflows as well as manage images on ECR. We support containers as well as VMs. You can start off with an Amazon managed base image, and we have a wide range of those images as well, starting from AL2 to Windows and many other flavors of Linux. You can also start with your own custom image. On this slide, I quickly talk about how you can leverage your CI/CD pipeline and incorporate Image Builder into your existing workflows. So in this diagram, we talk about how a code pipeline reads source code from code commit and then stores the latest version to your repository. Code build runs on build processes, and then at the end of it, it builds artifacts to your S3 bucket. Those artifacts are then easily available to be incorporated in your fully installed army. And then finally, when you have that army, you can easily replace instances from that army whenever you make changes to your code base. All of this flows smoothly through your CI/CD construct and can be fully automated on the AWS ecosystem. And whenever you create a latest image, you can easily test those images using the Image Builder test components and then release that army to production. That way you maintain a consistent baseline of your images and use that to sort of deliver consistent images to your service teams. On this slide, I will talk about the reusable templates that serve as building blocks for your automation frameworks inside Image Builder. As we talked about, we start off with a source image that can be selected from a varied range of your existing OSs. And then we start customizing it through a construct called Image Builder Component, which is essentially a YAML-based script that details your build customization and test use cases. Then you specify your AWS infrastructure to build and test your images in the infrastructure settings. And finally, you can control the distribution in the distribution settings and easily share your image access with your destination accounts. All of these specifications and settings are captured in a reusable template called an image recipe. And that image recipe can be used across different image pipelines in your EC2 Image Builder service. The end-to-end automation from build to validate to test to distribute is executed by your image pipeline. So at this point, I would like to hand it over to Sahil to talk about more hands-on use cases in the EC2 Image Builder console.
Thanks, Girish, for introducing the EC2 Image Builder service. So let's get started. And now let's go to the EC2 Image Builder console. So if you have used the service before and you have created any pipeline or so before in your account, then you will directly be landing to the image pipeline space. But in case you are a first-time user and you have not used EC2 Image Builder before, it will directly land you to the landing page of it. Let's actually solve a use case where I want to create a Windows 2022 image with certain set of components installed over it, and I want to distribute it to some other accounts. So let's get started and create an image pipeline. So image pipeline has basically three different sections. First one is the image recipe, second one is the infrastructure, and third one is the distribution configuration. These three are the main components of an image pipeline. I'll go over and explain each of them while we are creating the image pipeline. But for now, on the first page, in the first section, we have to just specify what's the name of the pipeline and some other details of an image pipeline. So I'll say Windows 2022 with custom component. Okay, so I'm creating a Windows 2022 custom component pipeline, and the main target of this pipeline is to create a Windows 2022 image with certain set of components installed over it. Basically, the software is like, I want to update my operating system, I want to update the Windows operating system, I want to update the time zone of it, and I also want to add couple of security components so that my golden image is secure. So I'll specify the pipeline name over here, and then there's one more feature called enhanced metadata collection. So it's basically about, if you check this box, that EC2 image builder in the behind the scenes, it will collect all the list of softwares installed on your system, on your instance, and then it will capture all that entire list, and then you can retrieve that list after you are done creating the output image. So this is a very cool feature where you have the option of collecting all the softwares and operating system softwares installed on your instance, which is nothing but enhanced metadata collection, and it's only available for the armies. It's not available for containers. And the second section of the pipeline detail page is the build schedule. So build schedule is kind of interesting, where you don't have to sit and manually start your pipeline every time you want to create an image. You can tell image builder what schedule you want to run the pipeline. This way you don't have to worry about managing the latest images of it. So for a simple use cases, every time, if like we have frequent releases of new Windows patches, new operating system, new versions of it, and then we also have latest version of our security components and softwares. So you don't have to sit and wait, and you don't have to sit and track about the latest version of those images and the components. You just simply tell that I want image builder to run my pipeline on so and so particular date. For example, in this case, every Monday at 9 o'clock UTC time, just trigger my pipeline, and then wait for and just create a new image out of it. So this is a scheduled build, and if you're not happy with the provided list of options provided by the image builder, you can also specify your own cron expression by creating your custom build schedule. And if you are not sure of either of it, you can just set the image pipeline to run manually. By manually, you take the responsibility of triggering the pipeline to create the golden image. For this use case, let's specifically create a pipeline which runs every Monday at 9 o'clock UTC time zone. And you can also add a couple of more options to this feature by basically telling that I don't want to use my infrastructure resources. I don't want to create an image if there isn't any update to any of the base image. I only want to create my image when there is a new version of the Windows available, or when there is a new version of the software available. So these two options highlight on that. First one is pretty simple and straightforward, where you are accepting that you want to run the pipeline when irrespective of the software versions and all. And then the second case, you're specifically telling that I want to trigger my pipeline at the scheduled time only if there is an update to any of the dependencies, such as base image or any of the components. So for now, I'll select the base dependency update option, and you can also add tags to the pipeline. Tag key. So with this add tags on the image pipeline, it helps you in identifying your resources and tagging them, and then so that you can audit them later on. It's easier to find out what all resources are there. So we'll go to the next section, which is basically the image recipe section. So image builder, image recipe is one of the key component of the image builder pipeline, where you basically tell about the base image and the components you want to install. Image builder provides you a unique way that you don't have to create a new resource for creating new pipeline. You can reuse the existing resources, or you can create a new resources. For example, if I have already created an image recipe, I don't have to go through the entire flow of creating a new recipe on the console. I can already select some of the existing recipes, as you can see I've created in the past, or I can go and create a new recipe. So I'll go over and create a new image recipe, and up over here you can see there are two different type of image types which image builder offers. You can either create a Docker images, or you can create an EC2 Amazon machine image. And up over here in this section, I'm gonna specify the recipe details just like I did for my pipeline. Windows 2022 recipe with custom component. And then I can specify the version of it. So once I'm done specifying the details of the image recipe, just the name and the version of it, I can actually go ahead and select the base image. And this is one of the key advantages of Image Builder as a service, because it provides already a preset of already managed a set of managed images, so that where you don't have to think about, or you don't have to go to the EC2 console or somewhere else to find the ARMY ID of it. Image Builder keeps a track of all the latest available ARMY IDs via Image Builder managed images. So up over here, before even selecting any image, these are the list of the options of the operating systems available, and we are continuously working on the inside the team to provide more and more operating system support. For now, we have 6 major operating systems available, as you can see. For this use case, I'll select a Windows image. And even before jumping over to this, I want to add a bit more details on the custom ARMY and the import basis. So basically, if you're not happy of any of the 6, any of the provided managed image by Image Builder, you can also select a custom ARMY ID from the EC2. So by that, we are not restricting you to use only our managed images. We are also giving you an option to provide your own custom ARMYs. And the third part is that importing a base image, and importing is basically you're using the EC2 VM import export service, where you want to import a virtual machine image into an EC2 image builder. So Image Builder also provides you that option as well. So for this use case, let's go ahead and select any of the managed image for now. So I'm going to select a Windows managed image, and as you can see, once I've selected the operating system, Image Builder provides me few bunch different options, where basically I can directly start with any of the Amazon managed image, or I can select with the images which I've created in the past via Image Builder pipeline, or I can also use any of the images which has been shared with me by some other account, any of the Image Builder image shared with me in past. So in this case, let's start with the Amazon managed image. As you can see over here, there are bunch of other bunch of list. There's a list of images provided by the Image Builder as a managed image. For now, I'll go ahead and select a 2022 English full base x86. So for that, and this is the next and interesting part of the Image Builder image recipe, where you have the option to select the latest version of the image every time the new pipeline is built. For example, up over here, I've selected the latest available OS version. Second option is to use the selected. For example, this 2022 Windows 2022 ARMY has 4 different versions, where it's like major is 2022, minor is 6, 7, 8, 9, and the patch version is 10, 14, 13, and 15. So these are the major minor versions of the Windows 2022 ARMY. I can either directly specify that I always want to use this specific version of the ARMY of the image, or I can also specify that whenever there is a new version of the 2022 ARMY, that only select for my image pipeline. So by this way, you're not tracking down the major minor versions of your image. You are simply just specifying that I want this specific version of this major version of my ARMY, and just use that, and not specify any other thing. So this cool thing is called semantic versioning, where you can specify the major, minor, and patch version of the images, and by that, Image Builder already take care of the image, of the latest version of the image. So for this use case, let's go ahead and select use the latest available operating system. And then the next section is the infrastructure instance configuration, where you basically have the option to provide the user data. This user data is nothing but the user data which you use while launching an EC2 instance. So Image Builder also provides you to add the user data, and by that you can define some network configurations or execute any script inside that in the user data, which will be executed during the instance launch in the EC2. So Image Builder has integrated experience with the user data of EC2 so that you don't have to manage it. So once we are done updating the working directory, let's go to the component section. Components are nothing but a YAML script where you specify the different actions you want to take or the softwares you want to install on your instance, on your army. As you can see, there are a bunch of components like CloudWatch Agent. You want to install any Corretto versions of it. You want to install Kinesis Agent, Anaconda. So all these are pretty big list of the components you want to install on your army. So for now, I'll select Chocolatey. And one of the component is update OS. So this component is basically used by Image Builder, and it will make sure that your army, whenever the pipeline runs, your parent image is always updated from the Microsoft repository, and then it always fetches the latest patches of associated to that image. So update image, and then next one I'll go ahead with a .NET. Yeah, as you can see, we have bunch of .NET components as well, and then I'll select one more related to security. So Image Builder has a stake applied component where we basically test your Amazon machine image against certain security guidelines provided, and then you can view all the results of all these all the security vulnerabilities and all in your image in the CloudWatch console. So I'll select for that. And in case I'm not happy with the provided list and I want to use my custom component, I want to execute a custom script on the instance, I'll use created by me. For now, I've created a component which will basically update the time zone. And let's go over to the component which I've created already. So this is the component which I have created, which will basically update the time zone to Greenwich. And you can see up over here, this is the YAML script associated to the component where I'm basically creating a build step and I'm updating the time zone. And up over here, I'm just setting the time zone by running a PowerShell command. So you can add any number of steps to the build, validate, and test phase of it. So the interesting part over here is you don't have to create separate components for build and test phase of the image. You can create just one component and specify different phases inside that. And by that, Image Builder will automatically take care of what scripts or what sections to execute in the what phase of the Image Builder pipeline. So for example, these steps will only be executed inside the build phase, the build and validate, while your army is being created. And this will only be used while executing the test phase of your army, where Image Builder will test your base parent image or base image with a certain set of components. So let's come back to the component section, to our pipeline. So till now we have created a build component, and then up over here, if I scroll down, I'll see these are the certain list of components which I want to install or execute on my army. And then interesting thing is I can also change the order in which the components will be executed. For example, for now, this is the order in which I've added the components, and they will be executed sequentially one after the other. And in case, for example, I want to update my windows before any of it, I just have to simply drag and drop so that my components are executed in a sequential order. And then I'll also update the time zone. And then, yeah, so this is the list in which the components will be executed in the order. And then interesting thing is similar to image, like I can select the major, minor, and patch version of the image. I have the same option to select the versioning of the operating of the components as well. So for example, here I'm specifying I always want to use the latest available version of the component, or I can also specify any specific version of it. So for example, I will specify 1.x.x. and says that it is available. If you specify anything outside of it, it will clearly tell you that the component version is not available, and it will throw out an error for you. So this is a cool feature of image builder where you don't have to track the versions of your dependencies, and image builder will automatically manage it for you. So once I've selected the build phase component, as you can see over here, I've selected the build components. I can also select bunch of same test components as well, which will be executed during the test phase, and image builder will take care of image builder will take care of executing them on the instance. So for now, I'll simply select any of the available component, for example, inspector test component, which basically triggers the inspector service to run on the base army. And I can also simply provide a simple reboot test where it will just image builder will reboot the instance so as to verify that an army can be launched, an instance can be triggered from that army. So once I've selected the components similar to the build components, I can also move around the order in which the components will be executed, and I can also specify the latest version of the component. So apart from that, you can also add a bunch of storage volumes to your instance so that you don't run out of space while executing your components and all. So for now, I'll just go with the default storage volumes to my army. And then similar to the pipeline tags, I can add the recipe tags as well. Image recipe key, recipe value. Again, an image builder image recipe is a resource created inside the image builder, so you can use these tags to identify the resources created inside image builder service. Let's go forward. And yeah, now the third phase is the specifying the infrastructure configuration. Infrastructure configuration is critical because here you specify what infrastructure you want to use for creating an output army. For example, we'll walk over all the different features provided inside the infrastructure configuration, but just before that, I want to go over the couple of things. It's basically similar to image recipe. You have the option of either using any existing infrastructure configuration, or you can create your new one. Or if you're not sure of the infrastructure, for example, you're not sure on what instance it will run on, what infrastructure you need and what permissions and all you need. So image builder provides you a default option where it will provide you the default list of everything, and it will take care of it, so you don't have to go ahead and think about the infrastructure details of it. So for this use case, let's go over the infrastructure part of it. Similar to image recipe and image pipeline, I'm also going to create one more resource called infrastructure configuration. So let's create that. Okay, so this is the IAM role. I can specify the IAM role to be used for that. So this IAM role will be attached to your EC2 instance, and it can have all the permissions you want while executing your components on the instance. Next part is specifying the infrastructure configuration, which is basically you want to select what instance I want to use. For example, I'll use a C3 large and I'll use M1 medium and 3. So it's nothing but the complete set of EC2 instances provided by the EC2, and is just mapped over here inside the EC2 image builder console. So you provide a list of instances on which you want to run your image builder pipeline, and then image builder will pick any of it, and then it will trigger the image pipe and it trigger the build phase and the test phase of the pipeline. So I've added the instance type, and the next part is the SNS topic. So SNS topic, like Girish mentioned, it helps you in creating an integrated experience with image builder and the other services. For example, you want to get notified once the pipeline is completed and the image has reached a terminal state. Like for example, image has been succeeded or failed. You don't want to sit and continuously poll the image builder service. so that to check the status of the image, you don't have to do that. You can simply add an SNS topic over here, which will basically get a notification, which will basically send you a notification of the image output result. So I can specify that. And apart from specifying the instance type and the SNS notification, you can also add VPC settings over here. You can either choose a default VPC or you can provide your own VPC network. So once you have selected the VPC, you also have the option to specify the subnet IDs and the security groups you want to attach to the instance. So all this is related to the EC2 instance, what will be used during the image build process. And apart from that, you can also specify a couple of troubleshooting settings where you specify the key pair with which you can log into the EC2 instance and then actually run through the debugging logs of all the components and all, so that it helps you in adding an extra visibility to the what's happening on the instance. And then once you are done with the selecting the key pair, you can also specify an S3 bucket where you basically select where do I want to export my logs. So for example, I want to export my execution log, the component execution logs, to one of the AWS bucket I have. And then a bunch of other settings about specifying the metadata version. And so up over here in this section, you can also provide the IMDS settings to your EC2 instance. We recommend using IMDS v2, but if in case you have a business need of using a prior version of it, we don't stop you from doing that. Image Builder provides option you to select both IMDS v1 and v2, but we recommend using IMDS v2. So for now, I'll select this one. Okay, once I'm done creating the infrastructure configuration, I'll go to the next page. Okay, so once the infrastructure configuration is done, the next part is the distribution settings of it. Distribution settings is one of the important feature provided by the image builder service because it lets you to distribute the output army to different organizations. AWS organization, it helps you to distribute the output army to different target accounts in different regions, and you can add bunch of configurations over it. So that's where image builder adds the value of providing a distribution configuration where you can distribute the army to a lot of resources or a lot of other accounts and all. So by as similar to the infrastructure and the image recipe, you have the option to either select any of the existing distribution configuration, so that you're not creating a new resource every time you're creating a pipeline. And you can, if you're not sure of it, you can either go with the default settings, which will basically distribute to the current region and will not apply any of the settings. So let's go to the creating a new distribution setting. Multiple region distribution. So I'm creating a distribution configuration where I'll be distributing the output army to different regions. So up over here, you can, as you can see, inside this is the settings for the first region, region 1, which is nothing but the US West 2. And then you can also add bunch of settings to the output army. For example, KMS key you can add to that. And then you can also use the target accounts, different other AWS accounts to which you want to distribute the army. Basically, you want to copy the output army, copy the image to the other account in AWS. And you can also add the output army name. For example, Windows 2022 output image. And yeah, so this is the basic setting of the output army, where you're just specifying the output army name and the target accounts to which you want to distribute. And then once you are done specifying that, image builder also provides you 4 different additional configurations for your output army. First one is the army sharing. So this is critical because you don't want to copy an image to the new account, because that takes a lot of time. It's a time consuming process because you're copying the entire army to a different account. Instead, what you want to do is, suppose you have like 10 different accounts in that region and you just want to copy it once and give the launch permissions to all the users in that account, in that group, so that you don't have to copy 10 different times. You can simply copy once and then add permissions to all those different accounts. So this is where you can provide the launch permissions. And apart from that, image builder not only provides you the target accounts, it also provides you option to share the army with an organization. By that way, you don't have to track the which account IDs have the permission to that army. It falls under the organization, so you can manage your AWS organization separately and not to worry about to launch permissions to that output army to that specific account. And once you specify the army sharing permissions, next up is the license configurations. It's nothing but you can add a license configuration to the output army to be okay. Once you have added all the license configuration, then you can also specify the launch template. So I've already created few bunch of launch templates, so I'll use that for now. And every time you specify a launch template, EC2 image builder will create a new version of that launch template and will use the output army of the pipeline to be added to that launch template. You can add up to five launch templates over here. For now, I'll add only one. So EC2 image builder also provides you to enable EC2 fast launch settings on your output army, so that you don't have to go to the EC2 console and find out your output army and then enable the fast launch settings on it. You can simply add it inside your distribution configuration and image builder will take care of it. So for example, for now I've enabled the fast launch setting on this target account ID, which is basically my own account ID, and you can also add the other account IDs as well. So this was the settings for one region. You can also add multiple regions over here. For example, I want to distribute my output army to US East 1, and the same settings what I've applied for the first region, I can also use the same for the second region. Once I've defined all the distribution settings to my pipeline, I'll go to the next, which is the last final review page. Up over here, we'll go through about all the different settings we have added to our pipeline to image recipe, infrastructure, distribution configuration and all. And then we will just review them and then start creating the resources. So for first section where we specified the pipeline details, is a recap. There where I've specified a pipeline which will trigger every Monday, every week at 9 o'clock. And then I've specified the enhanced metadata collection where image builder will collect all the operating system software versions installed on the instance. And then I've also specified that I want to run my pipeline on the schedule if there are dependency updates. I don't want to simply keep on running my pipeline. I want to trigger my pipeline or execute my pipeline only when there is an update to any of the base image or the component. And then next part is the image recipe, where I've specified what build components I want to execute, the different test components, what base image I want to use. As you can see, we selected the latest version of the base image. So image builder has automatically added x.x.x for the major, minor, and patch version. And by this way, I don't have to track of the latest version of this army. Image builder will automatically track it for me. And the third one is the infrastructure configuration, where I specified the instance types I want to use and SNS notification from where I want to receive, like which SNS topic to notify once the image pipeline is completed. And the last is the distribution settings over here, where I specify two different regions where I want to distribute and different regions where and different target accounts to which I want to distribute the output army. So once I'm done reviewing all the resources over here, I'll simply go and create the image pipeline. And behind the scene, what's happening is it will create an image recipe. It will create our infrastructure configuration. So once I've created all the resources over here, you can see my image pipeline was created. My recipe, infrastructure, and distribution configuration resources were created. And I can go ahead and see my image pipeline. So as you have seen that I've created a new image pipeline called Windows 2022 with custom components. and you can see all the details of the pipeline, like the image recipe, the infrastructure configuration, distribution settings, and tags. I'll talk about the event base later, but let me go through the image pipeline details first. So up over here, you can see there is no output image for now, as I've scheduled my image pipeline to every week on Monday at 9 o'clock UTC time zone. And then I'll go ahead and run the pipeline. So as you can see, image builder has started the execution of that image pipeline, and this is the output image, and still its status is currently pending. So image builder pipeline will take a while to create an output image because it runs the build phase, test phase, distribution, and bunch of other stuff. So it will take a little while. Meanwhile, I've created a new image. I created an image pipeline similar to this previous to the demo, where where there is a new available output image. As you can see over here, this is the output AMI ID out of this image pipeline. So this is all about the image builder pipeline. And the last feature of the image builder is to add event bridge rules. So this is also where an image builder adds value to the service by integrating with the other service like Amazon Event Bridge. So you can create an event bridge rule on the Amazon Event Bridge service and add the image pipeline as a target, so that it creates an integrated experience that, for example, you want to trigger your image builder pipeline when there is an update to any of the external service. Yeah, this was all about the image builder pipeline. Now I'll go back and give it back to Girish so that he can share about different future aspects of image builder, how to get onboarded, and bunch of other things, reference links and all. Thank you.
Thanks, Sahil. On this slide, we'll again summarize what we talked about in the previous sections on image builder. So there are three key phases in image builder that construct the building blocks of image builder automation: the build phase, the test phase, and the distribute phase. In the build phase, we talked about how we have a wide range of base OSs to pick from, and also you can start from with your own base image. We talked about the vetted templates available for build components, and we also addressed the flexibility of the build schedule, where you can initiate new builds either with software updates, time schedules, or some event triggers to initiate a new base image. In the second section, we talked about testing that output image to make sure it is compliant to your industry standards as well as your organization policies. And we also discussed how it is easy to troubleshoot with the CloudWatch logs and the logs available inside Image Builder. We talked about Amazon Managed Tests and how you can use those templates to create your own custom tests. And finally, we also looked at some preset inspector test cases that will help you mitigate known security risks. In the distribute phase, we showed how you can efficiently share your output image with destination accounts and how you can refresh your autoscaling templates with the latest image. Finally, all of these things combined help you make image management a hands-off experience and helps you manage images at scale in your broader CI/CD infrastructure. With that, I hand it over to Paul to talk about Launch Wizard and deployments of applications.
Thanks, Garish. Appreciate it. So you've had a chance to see some really cool features of Image Builder and how that can manage your image pipelines and do a lot of cool things for getting your environment set up. But that's only a piece of the puzzle, right? Because you always want to do more than just have an image. You're going to deploy an application on that image. And sometimes you know how you want that application to be deployed. You know how you want to set it up, and you can create your pipeline for doing that. But other circumstances, you may not know exactly how you want to set it up. You may want to try some things out, or it may be very complex and you're not sure what you want to do. And so there's other solutions we have to offer for that. And what are the challenges in setting up these applications? There's quite a few, and for those of you who have set up applications, you know exactly what I'm talking about. It can be super complex. You can have lots of things, lots of settings. You've seen some of the settings that we offer, even in just creating your images. There's numerous things that applications need in terms of security, storage, type of CPU, type of memory, what kind of security you need. I think I mentioned that before, but what kind of settings within the application itself. It can be quite complex. So many that I could spend a whole hour just talking about the complexities of setting up applications. And of course, because with complexity comes, it takes time to do things. If you've got lots of things you have to do in creating your application, it can be super time consuming to put that together. It can sometimes take literally weeks. Even I've seen some applications, because of the extent you have to go to deploy it, it could take almost up to a month to get it fully configured and ready to go. That's something that just most companies don't want to spend the time on or don't want to spend the effort on. And because these things are complex and because they're difficult to set up, of course, then you can make mistakes. And if you're doing something repeatedly, particularly if it's an environment that you ultimately want to use in production, you don't want to have those configuration errors. You don't want to have inconsistency in your deployments. You want to make sure that each time you do it, it maps to the preferences you have, to the compliance you need, and it's done in a manner that you can then make very repeatable. And lastly, you want to make sure you're using the best practices, not just best practices that you may have used in your legacy deployments on premise, but those best practices for the cloud that are tuned to the cloud, that take advantage not just of what the cloud has to offer, but the best ways to use things and the best way to optimize those resources. So what do we do to help with that? We have a service called AWS Launch Wizard that dramatically simplifies provisioning and configuration of very complex applications. We will literally guide you through each of the steps you need to go to deploy these complex applications. And for those of you who've done SAP, you know right off the bat, that's one of the toughest ones out there. It's a true bear to deploy. There's so many configuration settings. There's so many attributes. There's so many linkages with other things. It can literally, as I mentioned earlier, sometimes things could take as much as a month to deploy. SAP is one of those. I've been involved in actual deployments of SAP that can take over a month. But others, SQL Server, not so bad straight up, but when you do it in an HA or FCI deployment, can be very sophisticated, very complex to deploy. Remote Desktop Gateway, Amazon EKS. EKS is a really powerful environment for deploying containers, but creating that base environment can be challenging, and we can help you through that with Launch Wizard. Other services like IIS, setting up Exchange, setting up Active Directory, we can walk you through and guide you through the right size of instances to use, the right storage to use, and the right settings that should go around that from a security and a networking standpoint to make sure that you have the best environment you can have for your service. And we'll walk you through all the little bits. We'll look at the application specifications. We'll recommend those right resources to use. We'll then get you to approve all the bits so you're sure that the way we're going to deploy it will match what you want. We'll configure everything so that it's set up, and then when it's done, we'll show you what it has, and you can then work with that, what's completed, however you want to use it in the best format for you. So what do we do within Launch Wizard? Well, what we really try to do is take the benefit of all our years of running the cloud and distill that into our wizard to guide you through what are the best practices for deploying things. And we actually recommend people, if you want to deploy SQL Server or if you want to deploy SAP and EC2, use Launch Wizard. You'll get the benefit of all our experience and all our best practices and guide you through those deployment to ensure that you have something you can be confident will run well and run efficiently. Whether it's a single or an HA deployment or distributed, we'll help you automate those instances and storage selection. We'll help you estimate the cost so you can see up front how much is this deployment going to cost me so you can make sure that it's within your budget and the way you want to work. We will create templates for CloudFormation so that when you're done with your deployment, you can then reuse those templates in the future for future deployments. Don't have to worry about recreating the wheel. Once the wheel's created, it's there for you to use. We can track those, and we can actually save the settings as you're building these deployments up. And what's even really cool is when you're done with those deployments, if you want to just try something out, see how it works, and then go, you know what, okay, that was great, I'm done with it, we can delete that whole deployment from you right from within Launch Wizard. So it makes it super simple for you to spin stuff up, spin stuff down, and you don't have to worry about extra cost getting thrown into that. And the best part of it is that there's no cost to use. It's a service that we allow you to use. Of course, you have to pay for the resources you deploy, whether it's the instances or storage or whatever, but Launch Wizard itself is a no-cost service. And we've got lots of options for you. As I mentioned, you can do a kind of a standalone deployment on Windows. You can do a failover cluster. You can do an HA group, and you can also do SQL Server on Linux. You can do that as well on a standalone or in an HA group for always on. In any of these configurations, you can configure it, deploy it, play around with it. And like I said, if you're done with it and you don't want to use it anymore, you can also easily delete it because we'll track you all the way through. And that allows you to see, okay, how does my failover cluster work versus my HA configuration? Do I want to try it on Linux? I've never tried Linux before, so let me try SQL Server on Linux and see how it works. And I like it, but I want to stick with my Windows, so you can easily delete that. So it gives you that, not only that easy capability to set things up in the way that would be preferred, but also to try them out and see if it's a configuration you want to use going forward. So talked a little bit there about what Launch Wizard does and how it works. Now Brett's going to run through a bit of a demo to show you how that really comes out in practicality, and you can see all the details that go behind deploying something through Launch Wizard. Brett, over to you.
Thank you, Paul. For today's demo, we'll work through deploying one of our latest application additions, which is going to be self-managed Active Directory on EC2, launched into a new VPC. Now, this application is actually built on top of the corresponding AWS Quick Start template, which incorporates best practices based on the AWS well-architected framework, which I'll go ahead and just show you a quick example of what we're looking at for our infrastructure here. So if we hop back over to Quick Start. All right, so here we'll actually be able to see a quick glimpse of what the final infrastructure will look like once this deployment completes. We can see just the high-level design consists of a single VPC with 2 availability zones, both containing private and public subnets. The Active Directory domain controller instances are going to reside in separate private subnets per AZ, which actually allows Active Directory to be highly available, just in case any issues were to happen to either instance. Now, for deployments that include remote desktop gateway instances, which are typically utilized here as bastion hosts, these are going to reside in our public subnets inside of an auto-scaling group and provide secure remote connectivity to instances in the private subnets. So in other words, you'll connect directly to your remote desktop gateway instances, and then from there, you'll be able to jump over directly to your domain controllers in either private subnet. Now, while it's not highlighted in this diagram, you can additionally deploy a certificate authority and either a 1 or 2 tier public key infrastructure, which we'll cover a little bit later working through the wizard. Now let's see, for this one, this deployment it also utilizes a couple separate services such as AWS Systems Manager, which provides a suite of resource management solutions. Now for Active Directory specific, Systems Manager handles the automated operating system level configuration of both the domain controller instances as well as the RD gateway instances. And then we also have AWS Secrets Manager, which is going to be used for securely storing all credentials and any passwords used for this deployment. All right, now that we have a better understanding of the actual infrastructure, let's go ahead and hop into the Launch Wizard console. So from our landing page, we can go ahead and just click Get Started with AWS Launch Wizard, which will take us to our default home screen right here. So as Paul mentioned, we can see our existing applications that are available, SQL Server, SAP, and then we have our Microsoft-based solutions as well as Amazon EKS. All right, so for today, to get started with Active Directory, we'll go ahead and hit Choose Application. Now from here, we just need to drop down our available workloads and select Microsoft Active Directory, which actually brings us to our next screen. So at the moment, we have 6 different variants of Active Directory, 3 specific scenarios, which are each going to be placed into either a new or existing VPC. The first being Manage Microsoft Active Directory, which is an AWS service that we provide, but this deployment actually simplifies the entire process of delivering this, as well as configuring your management node if you were to choose one, completely automated. We have our deployment that we'll be working with today, which will be self-managed Active Directory on EC2. And we also have our third option, which is Extend On-Premise AD. This is a great option if you're currently just completely on-premise and looking to move into the cloud, or just looking to have a failover solution in case there were any disaster recovery events occurring on-premise. So for today, let's go ahead and select Self-Managed AD, New VPC, and hit Create Deployment. All right, so this takes us to the actual wizard itself, which on the first page here will be presented with a notice to review our IAM permissions of the role currently being utilized to initiate this deployment. Now, since each application may need unique permissions, we mentioned that a role containing administrator access policy will typically cover all the requirements here, but permissions can also be scoped down as needed to comply with any organizational requirements. So it's not mandated to have administrator access, but just for general purposes, we go ahead and just mention that on this page. So once we're assured of our permissions, we'll go ahead and hit next and then get into the details of our actual deployment. All right, on our next page here, we have configure application settings. So we'll kind of just work through each of these sections one by one. Our very first option is just enter a deployment name. So we'll go with something simple like demo for Active Directory. All right, in this next section here for simple notification services topic. So here we'll go ahead and leave this blank just for this demo. Our next option for deactivate rollback on failed deployments. So this is just a nice feature here that we have. So the actual underlying work that's done in the background will be through CloudFormation. If we enable this option here, if we have any kind of failure events during stat creation, typically in a default without this checked, you'll see that all of these will be deleted. So no resources, nothing to really fall back on other than just the actual events that took place. But if we enable this, this gives us the option to actually go back and maybe troubleshoot on the instance itself directly without having to worry about it being terminated before we get the opportunity to do so. So we'll go ahead and leave this selected here. All right, so our next two sections here for network configuration, EC2 configuration. Now these settings can technically be configured directly from their respective service consoles. So, going into our VPC service console, actually building out the VPC in each individual subnet for both private and public subnets, having to set up your security groups, ACLs, route tables. Now, one of the major conveniences with Launch Wizard is you don't have to worry about any of that. All we have to worry about here are a few select details that we want to include, and all of that work will be done in the background for us. So I'll go ahead and walk through these options just to get an idea of what we're looking at, and then we'll be able to see what this actually looks like implemented down the road. Okay, so working through here, our number of availability zones, we actually offer a maximum of 3, even though our diagram shows 2. So all of the deployment for Active Directory will be placed into just 2 subnets, but you can also configure a third, which will have just an empty private and public subnet similar to the first 2. And that can be used for adding individual or unique resources that you might want to just configure or launch, but it won't be affecting Active Directory in any way. So for this one, we'll go ahead and just select 2. We'll drop down our actual availability zones. So if you have any specifics in mind, you can select those pretty granularly. Otherwise, just go ahead and select what's most comfortable. So I'll stick with 2A and 2B. Right, next section here, we'll enter our VPC CIDR block. Our next option down here, we have Dynamic Host Configuration Protocol. Now let's see, so enabling this is actually going to create a DHCP option set, which is a group of network configurations that are used by EC2 instances in your VPC to communicate over the virtual network. So really what this means is once this option set is created, we'll actually be setting our domain DNS name as well as the IP addresses of both DC1 and DC2, which will be serving as both Active Directory domain controllers as well as DNS servers. And that will be applied to every EC2 resource that gets deployed into this VPC. So we're going to go ahead and leave this checked off and move on to our next section. All right, so next section here, we're just looking at the actual EC2 configuration. So our settings, we're just looking at DC1 net BIOS name. So although we list net bias, you can just think of this as being equivalent to the host name. So we'll go ahead and leave these as DC1 and DC2, as well as our IP addresses. Each instance is only going to have one ENI, so for the time being, you only have to worry about just entering one IP address. And the only kind of maybe small gotcha here is just make sure that these IP addresses do reside in both the respective private subnets. So private subnet 1 for domain controller 1 is going to make sure to have the same CIDR listing here, and same for domain controller 2. Right. So all of these settings, again, we'll just leave as defaults and move on to our next section here, which will be to enable advanced auditing and metrics. Now, this is kind of nifty here too. So by default, CloudWatch does provide a couple of values that you can use to monitor any of your EC2 resources. But with the help of the Amazon Kinesis agent, this setting will actually enable you to monitor a much more extensive set of metrics beyond those defaults. And that includes things like memory or specific disk performance statistics. It can also ingest event and application-specific logs directly into CloudWatch. And it's kind of a nifty feature here. We'll go ahead and just leave that unchecked for the time being, just for the sake of the demo. All right, so our next section here, we have our options for Cisfall and Ntds data drive size. Now, to speak briefly on this, so this specific deployment for Active Directory actually decouples both the Cisfall and Active Directory database, or Ntds here, by storing them on an independent EBS volume that's completely separated from the operating system. So this option lets you set the size of that volume accordingly based on your anticipated need for the size. So if you know that your database might grow at some point down the road to a little bit bigger than 10 gigs, you can actually preemptively set this to be any value that you want within the actual limits for EBS volumes. So if we want to leave this one at 15 gigabytes, we'll go ahead and just put that here. All right, so our next option will just be selecting the key pair name, and this will be used for just securely connecting to instances after launch. If you don't already have any key pairs, whenever you drop this down, you can actually go ahead and just select create new key pair name here. And it should take you just about a minute. Once you come back, you can always just hit refresh and you should see that ready for you. So we already have one created. We'll go ahead and select that. All right, so for our next section, we'll be looking at our Microsoft Active Directory domain services configuration, which will be the crux of what we're using for Active Directory. So very first option up here, we have our domain DNS name. I'll go ahead and stick with our default here, and we'll just use example.com. Okay, next section, we have our two options for setting domain admin username and password. All right, so next section here, so Active Directory organizational units. All right, so for anyone that's launched Active Directory, typically you're pretty familiar with the OUs that created by default, which would be something like computers, users. This setting here actually creates an extensive set of default OUs that you can use in addition to the ones created directly by Active Directory. And that'll include just a couple of new OUs that we can see here, such as domain elevated accounts, domain servers, service accounts, and domain groups. We can go ahead and check this one off. All right, so for our next section, we'll look at Microsoft Active Directory Certificate Services configuration. So this is going back to what I was mentioning during our review of the quick start diagram. With this deployment, you can actually set up and create a certificate authority. Right now, there are offers in 1-tier and 2-tier PKIs, and then move on to our final section of this piece of the wizard, which will be our Microsoft Remote Desktop Gateway configuration. So in this section, you can actually specify 0 remote desktop gateways, which typically requires having to connect to your domain controllers a little bit differently, which can be done either through Fleet Manager or maybe starting a port forwarding session. But for this case, we'll go ahead and just continue to use the remote desktop gateway, which again is just going to serve as our jump box where we can connect externally and then use that as a second hop directly to our domain controllers. And then our last section, this will actually be where you want to enter your public IP or public CIDR block that you'll be connecting to your remote desktop gateways from. Now, for the purpose of this demo, I'll go ahead and leave these values as the internal VPC CIDR. But again, that is one thing to note is that you'll want to use your personal external IP address. Right, so once everything is configured, we'll go ahead and hit next. All right, so our next screen here is where we have our configure infrastructure settings, which will actually show our sizer utility. All right, so we have two options with our sizer. We can base our suggestions off infrastructure sizings, or we can select from a drop-down of static values. So at the moment, all of our default values are set. If I scroll down just a little bit here, I can actually see what resource types are recommended. So for DC1, using 4 CPUs and 4 gigs of memory, we're going to see M5 to X large. Now this number will be here for each of the instance types, just as kind of something to keep them similar. But if we were to change our remote desktop gateway instance to 8 gigs of memory, for example, we can see here that M5 X large also houses at least the bare minimum specs for using 8 gigs of memory. But if we were to change our CPU cores to 8, now we'll see that this changes to M5.2X large. Right. So going back up here, if we want to take a look at our static values, we can actually see that we have a select set of instance types that we can use for each of our resources. So I'll go ahead and just select T3 medium for each of these really quick. All right, so if we scroll down here just a little bit, now you can actually see another cool feature based on the actual resource type that you select. So with our estimated on-demand cost to deploy additional resources, we'll see that our total estimated monthly cost for having 2 domain controller instances as well as a remote desktop gateway instance comes out to $129.60. Now, do keep in mind that the number here that you're seeing, this is strictly just for the EC2 resources that will be assumed to be running 24/7 for an entire month. It does not include prices like data transfer, NAT gateways, things like that. So just strictly EC2 resources. And we can see this should update here if we go ahead and change this to T3 large for our remote desktop gateway. And yep, we'll see that changes our price value here for the instance type as well as our total. If everything looks good here, we'll go ahead and get to our next page of the wizard. All right, so this will be for our post-deployment steps for our Launch Wizard application. So after you successfully deploy your applications, in some cases, there may be additional steps that you might have to touch manually. And then skip over to our step 5, which will be the last step of our deployment. All right, so on the last page of our wizard, which will be step 5, review and deploy. Here you can review all of the configuration details that you've entered up until this point. And if you were wanting to make any changes for something that, maybe you noticed a typo or just wanted to change just a small piece later down the road, you can actually see it from here. We can hit edit and go back and make our changes. So we're going to go ahead and hit deploy. All right, so that's looking good. All right, so right after you hit deploy, you'll be taken back to the console for Microsoft Active Directory. We'll be able to see that our deployment is currently in progress. And if we were to click on it, we can see the current phase that it's at in the deployment process. So we'll see things like creating secure parameter group, create a resource group. And one of the cool things is we can also go over to our configuration summary tab. And then from here, similar to page 5, our review and deploy, we can see all the same settings that we had just input there as well. So just in case you forgot or just wanted to double check, you can always just come right back here and take another look. Now, on average, depending on what settings you configure for Active Directory, these deployments can usually take around 50 to 65 minutes on average, give or take a couple minutes. So I wanted to go ahead and just present a completed deployment, which I had done ahead of time. So we'll go ahead and select our demo for self-AD. Now here we can actually see the full list of events that have transpired while the deployment was occurring. So earlier we saw we created our secure parameter, our resource group, but here we can also see where the VPC stack was created, the Active Directory stack, as well as the remote desktop gateway stack. All right, so let's go back and let's actually go back to our Active Directory console again and take a look at some of our action options. So if we go ahead and select our workload right here and then click actions and then drop down, All right, so I'm going to go a little out of order on this list here, but I'll go ahead and start with our resource group. All right, so this will probably take me to US East 1. Yeah, so let's go ahead and make sure that we're in the right region. So I'll go back to US West 2 in just a moment. All right, so looking at our resource groups, we can see both my existing demo self-AD deployment as well as our current demo AD. Let's go ahead and look at our existing one just briefly. All right, so if we actually go in here, this resource group is going to be a collection of all resources that were deployed with Active Directory, similar to as if you were tagging it, except this will be completely grouped just for simple management. So we can see our different types. We have Elastic IPs, EC2 instances, route tables, security group. This will really be composed of just about every single piece of this deployment here. So we can even see our secrets, subnets, our CloudFormation stacks. Really useful to have just in case you want to keep track of any of the resources that are coming from this deployment. All right, so let's go back, click 1 second. Now we're going to take a look at our, we can manage our resources on EC2 console. Give that just a moment to load. All right, there we go. All right, so based on the actual resource group ID that we just saw a second ago, whenever we select this option here, we'll be taken to our EC2 console with the resource group ID already filtered. So we'll be able to see all of our EC2 resources that were deployed. In this case, we'll be able to see our domain controller 1, domain controller 2, and our remote desktop gateway. Really convenient, just takes you right there. So for larger deployments, this can be really useful if you're looking at something with more than just a couple of instances. So you don't have to worry about trying to go and search through each and every single one. All right, so our very last option, we'll go ahead and hop back into our console over here. Pull this up. All right, so this will be, we can actually view the CloudFormation template and the stack that was created and deployed whenever we launched our deployment for Active Directory. Here we'll be able to see our demo self AD. Let me just take a look and make sure. Yeah, so let's take a look at our one that's already created. I'll go ahead and just launch this a little bit separate over here so we can have our nested stacks. So here we can actually see every step along the way of what was created whenever we deployed Active Directory. So here's kind of where we can see our VPC stack, our Active Directory stack, and remote desktop gateway stack. Each one deployed individually, so any issues for any of the stacks can be looked at, at a very granular level, not having to worry about trying to sift through tons and tons of logs. We can go directly and look at events, resources, or outputs. All right, so here we can actually see all of our resources. Was for our nested stack, which will be the root stack. We can have each one of our unique VPC, remote desktop gateway, and Active Directory stacks in here, and we can actually drill down into each one of these individually. This will come in handy here in just a moment, especially for remote desktop gateway. So if we take a look at events, we can just see things like we have our resource role, our domain join secrets, we have, let's see, our auto scaling group, our ALB listener, and so on. Now I'll go ahead and leave this open for a moment. So for the next part of the demo, I just wanted to briefly show you our actual instances that were deployed. So I'm going to go ahead and connect to my remote desktop gateway. But if you remember from what we looked at in our diagram, this is going to be using an Elastic load balancer to actually connect to the auto scaling group. So one of the really nice things with CloudFormation is we can go into our outputs tab here, and we can see we have an output for RDP URL. So I'll go ahead and just copy that directly. Make sure this copies. Perfect. All right, so I'll go ahead and just open up our remote desktop connection, put in our RDP URL, and hit connect. All right, so I already have these values here, but if we want to go ahead and just make this a little bit better. So the remote desktop gateways are already going to be domain joined, so we should be able to use our domain credentials. If you don't remember the password that you set up during the deployment steps, let's hop back into the console really quick just to take a look. We're actually going to go into Secrets Manager, as I mentioned earlier, which is going to have all of our passwords and credentials stored. All right, so let's go ahead and select that, give that just a moment. All right, so now we have our doubles from our existing stack and the one that's building right now, but we should just be needing to look at our demo self AD. I'll go ahead and select AD Alt User Secrets. That looks good, so we'll scroll down and hit Retrieve Secret Value. And we have our admin username as our domain admin, as well as just the generic password that we used during our deployment. So I'll go ahead and copy this here and hit OK. All right, and then we'll hit yes. Perfect. All right, so just like that, we are connected to our remote desktop gateway instance. And just to give a quick little look into what we have with our DHCP option sets, go into PowerShell and do ipconfig. So we'll actually be able to see our connection-specific DNS suffix will be the DNS name that we provided during the wizard. And the two bigger pieces that are really helpful with the option set here is actually listing our DNS servers as both our Active Directory Domain Controller 1 and Domain Controller 2. Right. So here we'll actually be able to verify that DNS is functional. So let's go ahead and actually connect to one of our domain controllers really quick. I'll go ahead and connect to DC1. All right, so example.com/admin, and then we'll use our same password that we're using. Hit OK. All right, so now you can see we're actually connected directly to DC1. And from the RDP session, we only actually had to enter the host name, didn't have to worry about the fully qualified domain name, which looks like I can at least verify our DNS is working like we hoped. Now let's see if everything is built out exactly like we're expecting. We'll go ahead and open Windows Administrative Tools, and we'll first start out looking at Active Directory users and computers. All right, so immediately we can see that our domain is set up and looking good. Our example.com, we have our domain controllers OU selected, and that is showing both domain controller 1 and DC2. Now, if we look in our computers OU, we can actually see our remote desktop gateway sitting in here. Since we don't have any other specific OUs for just general computer nodes, it'll just go into our default. And then from our users OU, we can see that we have our built-in accounts as well as the account that we set up as domain admin, which we should be able to verify here. Perfect. And just to go over a couple other pieces, I just wanted to take a quick look at sites and services. And this is one of the nifty features, is that this is completely set up and built out for you, so you don't even have to worry about managing sites and services. So here we can see our VPC CIDR. If we scroll down on US West 2 for our region, we can see our servers DC1 and DC2. And that looks perfect. And then for our very last piece, we'll go ahead and just verify DNS functionality. All right, so this is already open and set up. Go ahead and minimize that just to clear out some of our screen. So if we expand our forward lookup zone, we'll be able to see our domain for example.com. We'll be able to see DC1, DC2, as well as our name servers and under SOA. And down here, we do have our entry for the remote desktop gateway instance. So we know that that is connected and working exactly how we'd hope. So yeah, just from this alone, we can see all of the steps that you would have had to take previously. Deploying just the infrastructure itself can be time consuming. Even once you get all of that done, you still actually have to go and set up Active Directory on both your domain controllers, make sure your remote desktop gateway instance would be set up. But in just under an hour, on average, all of that will be done for you without having to worry about touching anything manually once you hit that deploy button. All right, well, I think that'll do it for today's presentation. I do appreciate your time and hope that this was helpful. So I'll go ahead and hand it back over to Paul now just to close things out. All right. Thanks, everyone.
Thanks, Brett. Appreciate it. So you've seen two great demos with Image Builder and Launch Wizard about how to help you create and manage and update your images and how to make it super easy to deploy complex applications and workloads. So with them, you can do tons of cool things. You can set up complex environments for proof of concepts. You can set up your QA, your dev, your prod. You can get things out super fast, super accurate, and ensure that you're using best practices for the cloud. So as I always tell everyone, when it comes to AWS services, the best thing is just to go try them. So go sign into your console, try Launch Wizard, try Image Builder. You can search for them right from the console to get to them. And if you want to learn more about what we talked about, there's some links here, a number of pages on documentation for Image Builder and Launch Wizard, as well as some material on GitHub on Image Builder, and some blogs that we've recently released about doing what we just talked about, deploying Active Directory, as well as IAS for Launch Wizard. So appreciate your time. Hope this was informative, and have a great day.